This brief video shows some exploratory results of using a long wavelength infrared camera, also known as a thermal camera, to record video of tree canopies for an entire night in order to detect and potentially identify wildlife present. Thermal cameras have been widely used for tree canopy wildlife detection, either handheld during nighttime walking surveys or mounted in drones looking down on the canopy. Both methods are effective, but due to the limited time spent looking at each location, fauna may be missed if their density is low and if they transit the area only fleetingly, or if they emerge from tree hollows only for some of the night. The camera was positioned in an area of tableland basalt forest about 100 metres upslope from Yellowbelly Creek, near where it joins the Upper Duckmalloy River, about 12 kilometres southeast of Oberon Township, in the New South Wales Central Tablelands at an approximate elevation of 1200 metres. So here's the thermal camera looking up at the canopy above its control box and battery. And this is the approximate view of the canopy as seen by the thermal camera. Thermal filming started at 6 p.m, but nothing of interest was really noted until just after 1:30 a.m. Note the small hotspot in the extreme upper right corner of the frame. This turns out to be a roosting bird, as we'll see in due course. So you can see the roosting bird circled in the upper right of the frame. A ringtail possum appears at the upper right. Note the thick prehensile tail and the way it confidently jumps between branches. Now we fast forward until the possum reappears. And we'll speed up the video to 4 times normal speed. We now jump forwards by just over an hour to 2:47 a.m. Again, at the upper right of the frame, a different animal appears. It appears to be longer than the possum with a different heat signature and what appears to be a long, thin tail. It's possible that this is a European black rat, Rattus rattus, but no black rats have been observed in the location, and it appears to be too big, bigger than the possum. Based on its thermal appearance, size and behaviour, we think it may be a ricali. You can see it circled in the upper right of the frame. As you can see, it appears to be stalking the roosting bird. And it attacks it. The bird flies off. Here's a close-up in slow motion. It looks like the bird might be a kookaburra due to the large beak and its size. Although ricali are primarily aquatic mammals, they are known to climb trees, sometimes up to heights of about 15 metres, and this is about 15 metres high. Next, we jump forward 7 minutes to 2:55 a.m. We see what looks like a possum roaming around the canopy. The video is speeded up by a factor of 8. Finally, we see what we have assumed to be the ricali reappear at the upper right of the frame. On close inspection, its thin tail is quite evident. It's clearly not a possum. It also seems to be stuck about 15 metres high in the canopy and somewhat unsure of how to get down. It certainly isn't leaping from branch to branch like the possum we observed earlier. We'll speed up the video by a factor of 8 in the interest of time. Nothing else of interest was observed for the rest of the night. Overall, it appears that there may be advantages to overnight observation of the tree canopy compared to walking surveys or drone overflights using similar thermal cameras, especially when trying to detect sparse and/or highly mobile arboreal fauna. These cameras can be configured to observe for several nights in succession on a single battery charge if required. Definitive identification of species may not be possible at the 640 by 512 pixel resolution provided by the thermal sensor used here with a 9mm moderately wide-angle germanium oxide glass lens. However, it should be possible to develop a dual thermal camera installation with a telephoto lens-equipped thermal sensor on a dual-axis servo mount steered by computer vision algorithms fed by the wide-angle thermal camera as used in this video. That would enable tracking of all moving objects with a warm thermal signature with sufficient resolution to allow confident species identification. However, for some species with very specific appearance and behavior, such as greater gliders or koalas, the current thermal camera setup as used here is probably sufficient. We will be publishing more results of our biodiversity research throughout 2026. Please subscribe to our YouTube playlist if you're interested. For more information, or if you'd like to support our work or become a member of OCSN, please visit our website at oberon-citizen.science.